Welcome everyone here. Let me hope you got the Wi-Fi password and are all set to go there. I just really want to quickly say hello. You're at Northeastern University. I hope some of you are confused because you think Northeastern University in the Northwest is a little weird and you're not in Boston. But here you are in Seattle. We opened a Seattle graduate campus of Northeastern University about 4 years ago now. So we have 500 students. Our biggest program is our Master of Science in Computer Science. We are a graduate campus, so our programs focus on master's level degrees, as well as some new boot camp and training programs that we've started in the data analytics space. So that's why you're here, and that's why we fed you and brought in Daniel today, because we're really diving in deep on the data analytics space. And if you're interested in learning more about what we have to offer as far as our fall programs, which include full-time and part-time boot camps in data analytics, as well as a new thing we're working on with Amazon Web Services, if you're interested in cloud computing. And we'd love to talk to you. We got Ricky back there and myself. As well as if you're looking to continue your education, if you want to get a master's degree, you want to level up your programs. Our computer science program is 200 students currently enrolled in it this fall, and we're doing really amazing work there in partnerships with the community. Our students are getting amazing jobs at probably a lot of the places you're already working at, or want to be working at. So come chat with us to learn more. Just by attending today, you are eligible for 15% tuition discount on any of our level data analytics programs. So if you want to start this fall on leveling up those skills, do it with a discount. And I will turn it over to our really great talks. We're really excited to be here today.
Thanks, Jessica. And thanks so much to Northeastern for sponsoring tonight's awesome food from El Canyon Catering out of Ballard. It's pretty delicious. Hope everyone's had some and is enjoying it. So we've got two big talks coming up about AI and politics and AI and advertising. But we're going to have Dan come up and give a quick overview of his new open source project that has something to do with notebooks, which I think is like IPython notebooks, but he's going to give a better description than I can.
Yes, hi, my name's Dan, I'm from CodeWork, but I'm here to talk about a notebook project, an open source notebook project for Python, and we actually call it the Unnotebook Notebook. And the reason we do that is because it's BYOI, bring your own IDE. So it has all the advantages of working in PyCharm or whatever it is, it's the Python notebook. And then it also, since all the files are individual, it makes versioning way easier, it makes it go straight to production a lot easier, and being able to do real code reviews instead of like things like Jupyter. So this is a project, and we're just about to open it up, get people on it, get the UX all ready. The project's been in the works for about a year. So anyway, I'd like to pass this around, and if it's something you're interested in, I put my email address on the top. You can ping me, and I just ping you and say, hey, it's ready if you want to try this. And also, a warning, you'll be the early guinea pigs. We have people, different people waiting. We're looking for folks who want to give us some feedback and help with this project. Or you can just put your name on it, your email, and as soon as it's ready, I'll ping you. So either way. But we really appreciate it, and that's the other notebook.
Thanks, man. Next up, we got Nathan, who's going to give us a quick spiel about some sort of awesome Twitter bot hackathon. I know that sounds interesting to me, so give it up, Nathan.
Sorry, I thought I was getting skipped. So Puppy, the local Python users group, in conjunction with Twitter, are doing a Twitter bot hackathon. And that's going to be September 10th and 11th of the weekend. And it is actually in this exact same space. It's going to be free. We're doing a workshop Saturday morning, which is geared towards kind of beginning and intermediate bot developer. developers. It'll be somewhat Python-centric, but there's no requirement for the hackathon that you use Python. You can use whatever language you prefer. In addition to Twitter sending some people out to talk, we're going to have people talking about natural language processing, about what the city of Seattle is doing with open data sources, and a couple of other topics like AWS. So if you are interested in attending that, either the Saturday morning workshop or the weekend-long hackathon, you can check us out at letsmakefriends.org. That's letsmakefriends.org, or on Twitter at LMFhack. And again, free tickets, and come out and make some friends.
All right, now for our first talk, Dustin Hart is going to give a talk about artificial intelligence and the 2016 elections, which is very timely, and I think it'd be pretty freaking awesome. So give it up for Dustin, and let's get the show rolling.
That's the guy who likes he's talking about politics. So, we're going to talk about artificial intelligence in elections. More specifically, controlling the narrative with artificial intelligence. I'm Dustin Hart. Thank you guys for having me out here. It's probably going to be a little bit more of a lay scientist speech compared to the one that's coming up, but I think you guys will still find that interesting regardless. So we're going to talk about AI and influence on elections now and into the future. As you can tell, I'm very serious about this. But I guess all of you guys can agree we can't take it too seriously, or else you won't run screaming with this year's election. So I'm not going to talk about preferences or anything like that I've got, just cold hard facts and what I've found and discovered. So, what if I could tell you, with a high degree of confidence, who will win this year's presidential election? Your first thought would likely be about the methodology used, probably with a focus on the analytics done by aggregate polling outfits like Real Clear Politics or 538. Your second, if politics is something that intensely interests you, is that August is generally too early a time to call the outcome of an election, even using aggregate polling. So, though that means I could possibly say I know, it's curious, I'm sure, how I could know. So, one of the questions I'm going to answer today is who I believe will win, and how I reach that conclusion. And my remote just lost its connection. There we go. Okay. So, we'll get into that later. Yeah. Okay. A better question, though, for today is what are the parameters that can affect the outcome? And how can we change them? I've been spending this election working towards determining that answer. This project has been the culmination of my interest in three things: political science, sociology, and AI, which is pretty much the trifecta that means I never get invited to parties. For the sake of making the best usage of time, I split this presentation into 2 parts. We'll talk about the history of political campaign advertising, leading up to now, and then we'll talk about what the future is going to be like, and how we can counteract some of the stuff that's going to be coming out in the next campaign season. So, let's talk about history. I'm not going to bother with like the ancient Greek democracy or any of that. We're going to jump a little bit further. 1450s was the invention of the caricaturas, which was created by Leonardo da Vinci, Agostino, and Annibale Carracci. These are the caricatures. It expressed exaggerated features and those things, you know, that highlighted potential oddities about a person in a humorous manner. It moves into the early beginnings of the 1500s. During the Protestant Reformation, Martin Luther utilized woodcuts that were caricatures in nature and juxtaposed religious scenes with higher figures of the Catholic Church, one against each other to point out hypocrisy. And then finally, the first major usage for politics, William Hogarth, the grandfather of the political cartoon, and judging by his portrait, was a satirist who had an objection to the current state of affairs and made a lot of hard work to point that out. It effectively amounted to the first actual political cartoon. So we get into the first American political cartoon in the 1750s. It was The Join or Die by Benjamin Franklin. It talked about bringing everybody together and sent a strong political message. It was the permanent fixture of the American politic. From the very beginning, political cartoons were a very important thing in American politics. So I'm sure a question's on your mind right now, which is, what the heck does that have to do with today? Well, if I can stop losing the connection, I can make it tell you. Okay, they were exaggerated in nature, they're repetitive, and they have text or situational cues superimposed on them. I'm not sure if there's anything else out there that has similar characteristics. So we'll get back to that. We'll talk about other techniques. Canvassing, which has also been around since the inception of America. People going door to door, talking to people. Protected by the First Amendment, and basically guaranteed to make a lot of people annoyed, but it's something that is done, and is still done to this day. And we get into the first attack ad. This was the Daisy Girl in 1964, the election of Lyndon B. Johnson versus Barry Goldwater. It was the first attack ad and has been the most poignant attack ad in American history. These things are important historically because they are the basis of what is the large portions of political campaigns. They're multifaceted. They have a direct nature that is supportive of their own campaign, an indirect nature, attack ads, push polls, whatever. And then you have very deliberate subversive attacks like the Swift Boat Veterans for Truth with John Kerry. And it frequently uses the most popular form of media, which is how we get into today. The progression of advertising has gone from newspaper to radio to television and now to the internet, from canvassing to telephone phone banking to digital phone banks. So now we get to the present day, where digital phone banking, social media analysis, target marketing, grassroots campaigning, and coordination are performed. All of these rely on big data in order to strategize and know where to direct these things. Digital phone banking, in particular, is a mixture of analysis of actual known voting records, like not obviously who somebody voted for, but who's in which political parties and what the statistics are about their age groups and their demographics and what they're likely to do and what interests them. Oh, and also traditional advertising. But that one's actually not that important this year. 2008 marked the very beginning of traditional advertising's decline, with Obama being what was called the pro-social media candidate. And even his campaign utilized big data to better form an impact. So there's many organizations that are using big data for campaign analysis. Groundwork on the Hillary Clinton campaign, Revolution Media for Bernie Sanders' campaign, Applied Memetics for Ted Cruz's campaign, Correct the Record, once again for Hillary Clinton. In particular, what they focus on is analyzing trends in various websites like Facebook, Reddit, etc., and they will direct traffic of their users towards those sites, and they put in their own comments to correct the record, so to speak. There's Draper Sterling with the Trump campaign, and Cambridge Analytica, and that one's actually kind of important despite the fact that they're not involved anymore. They were a service being used by the Ted Cruz campaign. In Iowa, they had broken it down to every detail they could possibly give to canvassers about whose door they were going to knock on. That data was fed into their phone so that they had a pretty good profile of who was at the door and what they're likely to be interested in when you're talking to them. And this is only going to continue to get more aggressive. There's been tools of mass coordination. Early culmination of this, in fact, one of the first that I've seen, is Megaphone by Give Israel Your United Support. It utilized basically a hand-fed analysis of various websites that had polls and message boards and coordinated prompts for users to go act on those. Mass coordination tools are kind of similar to digital phone banking. Some tools are now using natural language processing to determine the context of the articles. And even some are using sentimental analysis to determine if there's a call to action. But largely, still to this day, it employs humans. This is an example of Megaphone. It says voice your opinion, vote for Israel and CNN survey, and provide a link. The user will click that link, they'd go to the website, and it would, at some points, before they got rid of that feature, would automatically vote for you in that poll. So it was a nice way to distribute people's influence on public polling. And this is a very genericized example of one utilized by both campaigns now. They are taking advantage of gamification by giving you points for every action you can take on the app, whether it's phone banking by calling somebody, or voting on a poll online, or watching this video on YouTube, or sending this video to your friends. In fact, you might have actually gotten a lot of campaign rhetoric from friends who were using apps like these. So then we get into personalized advertising, where people are stratified by their various social media groupings. The market copy is specialized for the target demographics that have been determined, and A/B testing is used within groups to retrain their copy and determine which is the most effective phrasing to get voters energized. So we get into the future of the campaign. It's going to be campaigning at the individual level. There have been a few people who are AI specialists who have been talking about this, warning about what is to come in the next election season. And it is analysis of each individual user who frequently posts online and an attempt to influence their opinion. So we'll cover the scope of that, talk about the central hypothesis, some methodology that we use to achieve this, and I actually experimented with this myself, and so I'll tell you what the results are. So, going to get into about scope. Largely for this experiment, the focus was on social media, with sites such as Facebook, Twitter, Reddit, and yes, 4chan, and mainstream media websites like ABC News and MSNBC, NPR, and Fox News, and several other prominent news sites, most of which use Discuss, which makes it easy to repeatedly bot out against these things. So let's get to the central hypothesis. An army of intelligent bots can sufficiently blend into communities and influence public opinion to change the outcome of the primary and general elections. So let's talk about methodology. So we need to know how we're going to do this. How do we determine how to influence? And in order to do that influence, you're going to have to perform content generation through direct communication and indirect communication. And then also we'll talk about how to coordinate that. So let's talk about the determination of influence. I'm sure at this point, a few of you are starting to immediately think that there's something very wrong with this practice. And whether or not you do, it is very much a thing that is going to start happening. And unless campaign laws change, it's not going to stop anytime soon. So, utilizing the research work done by Huang, Passiliao, and Dixon, they wrote a journal article called Containment Control for a Social Network with State-Dependent Connectivity. This journal article had funding from DARPA, and basically, as Lars Technica put it, it was finding a way to pilot people towards opinions like drones. Surprisingly, little media attention was actually given to this. Then again, maybe not too surprising, because it used fractional order systems, and trying to explain that kind of thing to the general populace is met with blazed eyes at first, and also trying to suppress a giggle when they get to the phrase locally lipschitz. So that may be part of the reason, but essentially what you do is you take a graph model of social networks and determine who are the leaders, or you can mark yourself as a leader using an influence algorithm they came up with. So in turn, you become the leaders. So how do you create the graph? I could talk very specifically into each of these different domains, Facebook having their own, Twitter having their own, Reddit having their own, and so on. Primarily, I will talk about Reddit today, and you'll see why in a minute. So we have a graph of some users, and these users have various directional connections between each other. How are these determined? The user on the left is going to be symbolic of one of the current major content generators on Reddit. They post frequently, and usually with original content. This makes up about 1% of Reddit's user base. Their content is consumed by roughly 90% of Reddit's users. These users are often marked by having more link karma than comment karma. The users in the middle represent a lot of the commenters. They are actually the largest sphere of influence. They are the commenters, they energize, they mobilize the majority of Reddit's user base, both readers and contributors alike. Their conversations are representative of the overall mood and beliefs of their user base. They constitute roughly 10% of Reddit's actual user count. Their direction is shaped by the content provided by the major content generators, but their spin determines the influence. These individuals are generally so... These individuals are generally strong in their opinion, so to influence them requires a sharp adjustment in content consumed. The group on the right represents roughly 90% of Reddit's user base. They don't comment often, or ever. They may not even have an actual account, in other words, a lurker. Influence is directed entirely towards them, and they have zero impact on the overall viewpoint of the community. Their opinions are driven by the topics and conversation they read. Parallels can be drawn to other forms of social media, but the same principles apply. So, from this graph, again, how do we determine who those people are? Well, fortunately, websites like Reddit can do that info pretty much off the bat. You have link karma and comment karma. That's a pretty good establishment for who are the main content generators and who are the main comment contributors. And from that, you can take those scores and use them as the weighting on that graph. And you can also determine from those scores what the likelihood of influencing another person is. So let's talk about creating conversation. This is where we start to actually get into the AI side of things. What are the traits of conversation on social media? They are disjointed, free contribution, like people can just pop in at any time and pop out whenever they feel like it. And it's often repetitive, and can be easily simulated with Markov chains. And you can use semantic analysis to determine what the favorability is of certain opinions. As you can imagine on websites like Reddit, there's a very negative opinion towards one of the political candidates. And you can tailor those chains using that semantic analysis to determine what is more likely to change somebody's mind. So in case there's people in the audience who don't know what Markov chains are, they are a predictive model for states in which the transition to the next state is randomly determined with preference or weighting based on the current state. Markov chains with order utilize previous states as well as the current state to determine what the next state will be. Adapted to language using a body of text, you can generate content from that. Higher order chains provide less randomized content, but overall are much more coherent. So first order Markov chain just taking one of the most common sentences, the brown fox jumps over the lazy dog, you can see that from the very beginning, the initial state of no word, it is 100% likely to go to the word be. And because be appears twice in this sentence, the word that immediately follows has a 50-50 chance of either being quick or lazy. And so on and so forth until you follow through the entire sentence. Higher order Markov chains basically capture two or more states to form what the next one will be. So semantic analysis. In essence, we're trying to determine the meaning of a sentence. It's a difficult, not entirely well understood problem, but practicality drives the constraints onto how you're going to try and tackle that problem. Emotional context is very important in this, and obviously so is the subject context. The subject context, of course, can be people, policies, events, or locations. So, to derive emotional sentiment from that text, you use what is called sentimental analysis. It is the easiest task out of this whole thing. The Stanford NLP library is actually the one that I've used for this. It does a pretty good job at it, actually. So, we're going to combine efforts of these things to create conversation. We're going to determine the subject, find emotional weighting. If it's negative, generate sentimentally positive posts. If it's positive, generate sentimentally negative posts in response. The overall goal is to see if I can convert 100 Trump voters to 100 Hillary voters, and vice versa. So how are you going to be a good actor? Because I mean, if you've got a swarm of bots running around on sites like Reddit, the first thing that's going to happen is the administrators are going to pick up on the patterns and kick you out. So visibly, you need to appear to be a normal user, so pick a browser, don't use APIs. You need to keep the random selection of your model, like the browser profile, for example, like a specific version of Chrome, consistent to your user, but randomized throughout your selection. And you want to follow a posting pattern that matches the time zone the actor should be in. Now that doesn't prevent somebody from being a 2 a.m. poster, but largely there is a bell curve of whether or not the user is posting at a given time. Intellectually, you'll want no ideological shifting from within an actor. You'll want to use different actors as the users you're attempting to influence will shift opinion. This is the leadership position that containment neutral article talks about. The style of an actor should remain consistent. Frequent commenters stay frequent. Lazy workers stay lazy. Username should have no predictable pattern, like noun plus number is going to be a giveaway if everybody has that pattern. Correct the record actually got copied from that one. Unless the goal of the actor is to induce chaos, you should never deviate too far from the target audience's current state. So, I have an example of this. So what we have here is we're going to simulate a social media thing. There's going to be 20 users that are die-hard Trump supporters, and there's going to be 3 bots that will be running around trying to change their mind. So it's going to be like a social network, but without any time delay. On the left will be the conversation flow, users will be in blue, bots will be in red, and on the right is the actual convergence diagram, where the simulated users will be represented as blue dots, moving from the right to the left. So let's begin. And just fair warning, there's going to be some pretty harsh language. I don't know if you are too familiar with some of the things that people do on websites like Reddit, but the more politically charged a person is, the more likely they are to curse.
Who's about to switch over to live?
That's a good question. The organizers know if there's a way to shut off the lights or dim the lights. Well, in this very difficult to see graph, this swarm of blue dots over here is the user base, and it's measuring their opinion. It's measuring their lexical similarity to other people who are Trump supporters, and then it's also measuring their emotional sentiment. Obviously, very angry. And so over the course of time, although this simulation is going to not be bound to the real world constraints, seeing as users don't typically post, a second within themselves over and over again constantly, we can see the swarm of dots slowly moving from the right down to the left, where at the very corner would be the central point of literally no desire at all to vote for that candidate. And also, this is going to take a little bit. It's got a lot to churn through. At some point, I think you can already see that the directionality is changing. Because we did start about over here, although I don't know if the cursor shows up very well. I couldn't hear you, I'm sorry. Okay. Each axis is one of the three things I was talking about. The top axis is sentiment. The axis that's going kind of horizontally roughly is the opinion, like the closeness of see. We can already start to see the opinions turn. When they turn purple, it's when they're starting to reach closer to equilibrium. And once they're all completely purple, their minds are effectively changed. This is determined also by syntactic proximity. So the words that they say become much closer to what, in this case, the Hillary Burger would be saying on websites like this.
How do we know the red ones are not box as well?
The red ones are not in the box. The red ones are effectively at about the 20% level here. Basically, it spans from 0 to 1, whereas 1 is of the most support or of the most syntactically similar or of the most emotionally charged, down to 0, which is the least of those. And at this point, they are changed. So, I mean, these are bots, so how about actually taking it into the real world? Well, conversations aren't everything. I mean, you can talk about generating conversations, but there are other forms. Indirect communication, get practical with it because there's no way you can completely control a conversation. There are certain factors of adoptability. 5 minutes left. Okay. Shock, distortion, simplicity, and also humor. You can test the tendency to become a meme through some of these metrics. Views, votes, if applicable, and comments, and also their repetition. So what's a meme? I mean, obvious answer. Most people here know what a meme is. But it was coined by Richard Dawkins in the Selfish Gene. The most modern adaptation is through regurgitation of photos and text, frequently using the impact font. Remember caricatures in political cartoons? Those are early memes, effectively. So we're going to do some dynamic generation of those things. I won't be giving an example of that today because we still have a little bit more to go through, but reposting existing popular memes is one of the ways you can contribute content. Modifying those things to enhance their adoptability. There are certain factors that can do that, like using artifacts or adding other forms of memetic distortion, like small face swapping, textual overlays. There's also forms of shock induction. And you can recurse through these different factors to increase their overall adoption. An example of artifact induction would be like algorithmic artifacting, like increasing, or I guess decreasing the quality of the JPEG. Resharing, like faking that it was reshared through something like 9gag. And emoji overlays, which is more common on the Instagram side of things than other social media, but it does get posted elsewhere. Forms of memetic distortion. Small face swap and replace, and text overlays. I mean, these are really common things that are used in memes, and they can all be very easily automated. I mean, most of you guys probably use Snapchat, and they have them as filters. So, Combinatorial distortion would be taking some of these tactics and putting them together, so base swap plus textual overlays. I'm going to go ahead and talk about shock induction, but I will say this, some of these pictures have disturbed people. They're not really that disturbing, but I know some people are sensitive to that, so I guess that's a trigger warning. The first is going to be cyclopia, by taking two eyes and merging them into one to induce shock. That was used against Ted Cruz at one point. Another is taking advantage of trypophobia, which I guess isn't technically a real fear, but that weird hole thing. Yeah. And using the deep dream generator, which I'm sure a lot of you guys have seen. So those are the various forms of shock induction. So performing actor disruption. Well, we'll have to go back and look at the graph. And from that graph, you can determine who are the people that you want to disrupt. Because you want to become the left. You want to become the #1 content creator. And you want the middle to influence the overall 90% of users. Middle groups cluster naturally around the left groups, and then the rest of the 90% gets caught in orbit. So you incite chaos from within. How do you organize chaos? Traits of chaos within a network is doubt, suspicion, high influx of conflicting ideas, all can be easily generated. Different networks exhibit these traits differently. Facebook and Twitter, high rate of combative, negative, positive sentiment, fluctuation of viewership and shares. Reddit, strong downvotes, inciting suspicion of moderators, opposition spam. On 4chan, extremism, as extreme as you could get. Declaration of opposition of shills, and reinforcement through additional image posts. Ensuring to avoid suspicion yourself is also pretty important. So, you have to be somewhat consistent, but you also have to make sure you're not getting caught. So how do you manage this? I used ACA, but their remoting leaves a lot to be desired. It's a pretty fragile little man. So I proxied the remoting through RapidQ. The provider is actually irrelevant as long as it's stable and fast, and also allows for external integration in the case of what I used. So we have a swarm of 60 bots on AWS, and we want them to communicate to the outside world. But of course, if you're just connecting through Amazon IPs, that's going to be pretty obvious and easily filtered. So you can use things like Tor, or private internet access, or other forms of VPNs. And I mean, if you're really, really unethical, because you could also use alternative things like botnets. What's the cost? 60 micronodes on AWS is $280.80 a month. Personal computer to direct the swarm, one that's existing. And the internet service is $70 a month. But seeing if the hypothesis is correct, prices. So is the hypothesis correct? You betcha. What are the outcomes? Users who were not diehard supporters would typically turn. As I said, targeted 100 Hillary supporters, turned them into Trump supporters. 100 Trump supporters, turned them into Hillary supporters. Reddit frequently took the shortest amount of time to actually sway opinion. The others were tougher cookies to crack. Mostly because I think Reddit has a higher trust in its own user base. That's not the widest. Mainstream news sites are heavily moderated, so bots kind of, like any that disagree with the media's own narrative, got quickly kicked out. NPR News, and I don't know if I was the only factor in that, but they disabled comments due to their inability to moderate enough. At the height, there was about 2,100 users that were contributing over 50% of the content, and of that 2,100, I know I was about 10%. So some observations. Candidate supporters more frequently use their opposition's name in organizations than other nouns, frequently prefixed with pejoratives. Trump supporters were more negative sentimentally than Hillary supporters. Hillary supporters were more negative than Bernie supporters. And Bernie supporters were closer to the control population sentiment score. Twitter, also in evidence of their own moderation, frequently took down trending hashtags which they leaned right. So, I mean, yes, this is obviously, there's some real impacts to this, but it's just Reddit, right? Why should we care if it's just sites like Reddit? 1 in 6 Americans use Reddit. It's an average of about 50 million Americans visiting per month. It's the 9th most popular website in the US, and more use Reddit for news than any other source. And I'm not just coming up with these facts myself. This came from Alexa. CNN literally gets less viewership than Reddit. It's also slightly overrepresentative of the demographics that are most likely to vote. So one of the questions that's lingering in the background is, how do you prevent this? Users that follow and post around specific users are a dead giveaway, especially if they're opposed to the political views of the person that are being followed. The HD account activity, if they're repeating a lot of things, but none of them are memetic in nature, they have consistently similar usernames, and especially if the accounts are not verified. This is an example of what was being done. I don't know who was doing this, but these were posts coming out on Twitter that were pro-Hillary. And almost every single person follows the same pattern: first name, last name, number. But the text is all the same. So the other thing is predicting the election outcome. And this is where things get equally interesting. Utilizing sentimental trends, the overall size and growth of the supporter bases over time, reactions to negative events and how it impacts those previous two factors, and blending it in with the actual poll data, provides a pretty good predictive measure. And so the winner had certain characteristics: consistently climbing sentimental score, albeit slowly, a rapid growth in support base, markedly, and negative events had little to no impact. And the polls are slowly acclimating in their favor. I think you can think who might be that person. So, this goes contrary to what the current polls are predicting, at least some of them. So, here's something very interesting. As far as social media goes, it has played a more critical role this year than it ever has. And we can't just assume what we used to assume in determining who's going to win. This is the trend over roughly a month and a half's time. The blue line, I guess I used the wrong color, the blue line is actually Trump. And he's stuck at about a 73% chance to win. We'll see how that goes over time. I plan on actually putting this data on my website. I'll share that link on the meetup group, and you guys can take a look at it yourself. So, thanks for your time.
Thanks so much for the awesome talk. If people want to do questions, I've got a microphone. Sorry. Okay, cool. We're going to do 5 minutes of Q&A, so fire away.
Thanks for your talk, it was very interesting. Can I find any resources in the internet about your work?
Any sources on the internet of this work?
Yes.
No.
About your contribution.
About my contribution, I will show it on my own website. I'll be publishing that data later this month. It's going to be a lot to churn through.
Can you give a link to the site?
Yeah, it's as I said, I'm going to put it on the meetup group, but it is antidecor.com. You'll start to see more of that show up pretty soon.
Thank you very much.
Yeah.
Hi, thank you for the very exciting research you have done. I don't know whether it's just my feeling, but I feel like when people are, posting things on their website without their real name, things tend to be more extreme, right? I was wondering what are the things you have done to reduce such bias that was constituted this to have a more fair outcome or prediction.
I'm sorry, I didn't quite understand the first half of that question.
So, when we're dealing with a lot of social media data, we have to deal with a lot of bias and noises. When it comes to Reddit, website like Reddit, we have to look at it from a probably slightly different angle than Facebook when we are posting normal opinions or ideas. When you're taking data from such website like Reddit or 4chan, what are the things you have done to reduce such bias to guarantee a more fair prediction outcome?
Oh, I see what you're saying. Okay. That data analysis is more than just on Reddit. It's also for Facebook trends, but it's based more on sentiment score and subscriber counts. So subscriber counts, I mean, they're a pretty static factor. Sentimentality, you can just basically take what the baseline sentiment is and determine what its distance is from the baseline on other places that are not so politically charged. Like, for example, the Pokemon Go group has less, sentimentally severe types of behaviors.
So all the users that you claim have changed their minds, did you follow and track them later to assess their sentiment in other like threads on Reddit to see if the effect was long lasting, if their opinion changed now, but maybe they switched back, or how long lasting that was? Or another one is a lot of people that might change their opinions at the time, if they are going against what they were claiming before, they might not participate anymore in the conversation. You might not get the signal that they actually have changed their mind, but elsewhere they might switch. So did you look at the lifetime of the users that were exposed to your comments and your bots to see a bigger picture, or was there only those comments?
This is actually something that that containment control document actually points out, which is, by and large, people's opinions don't tend to stay exactly the same over time. So the moment the influence is pulled away, it very typically will go back to what's more homeostasis for that given community. So the only way it works is with constant pressure.
Thank you, it's great talk. So I see you are using bots trying to influence individuals online. So I'm pretty sure this is probably not a similar attempt to be done using person. So is there any research to see any organized effort, whether using bot or using person, to influence political views on political candidates?
Well, I didn't do any testing with persons myself, like having myself or other people act as actors in comparison to bots. That already exists. Correct the Record uses that, or at least they pay companies that use that. It's obviously very effective, or they wouldn't be shoving $6 million into it. But as far as what I was doing, I was just more interested in seeing whether or not bots can do it. And that's probably where the future of things are going to go, because ultimately everything is automated.
Last question?
For solving this, you mentioned a set of things that you can do to identify these bots. Have you considered putting bots in the system itself who can identify other bots, and basically if the bot is trying to make if it's done from supporters and the bot is trying to go to auxiliary supporters, these bots, your bots basically try to preserve the homogeneous of the community by hacking those bots through verbally or something like that, just to neutralize their efforts.
That is actually a really good idea. That is something that websites can use, is that type of technique to try to reduce the impact of people who are using campaign bots.
Okay. And the second question, do you plan on putting the slides on the thing?
Those what?
Will you putting out the slides on the
Yeah.
Thank you.
All right, everyone give Dustin We're going to do a 5-minute bio break, and then right after the bio break, we're going to have Dr. Huang give an awesome talk about AI and the ad platform at Amazon. So everyone enjoy, and I'm sure Dustin will be around if you guys have more questions. Thanks so much, everyone.
Okay, can people move it? Yes. Right now, all right. Thanks everyone. So it's yeah, just wanted to comment. This Chocolate introduces AI for ads. So much like all of AI, a lot of the ideas behind this work came about in the 1970s, and we're just rediscovering them now. So it's a really nice example of everything that's old is new again. So what I'm going to talk about today at its core is really how do you do an online and distributed mathematical optimization in a real-time environment. And of course, I'll use the display advertising setting as a way to demonstrate this. So before I move any further, I definitely want to call out the various collaborators that we have at Amazon, spanning both research and engineering across multiple locations on Earth. So it's not just here in Seattle. And otherwise, if you're interested in the gory details, there's 2 references there that you can check out or check them later about. So of course, I'm from Amazon, so we're really big on Flywheel. So the Flywheel, it's one of our favorite things. So typically there's a flywheel for the retail business about how various activities reinforce growth in the company. And we have our own version of that over in the advertising space. And in particular, this flywheel has 2 major components. One which is programmatic optimization. That's what I'm going to talk about mostly tonight. And that's what these algorithms in to make real-time decisions and stuff like that. And of course, these such algorithms have to also work in partnership with manual optimization, so the activities and decisions made by actual human campaign managers and other agents. In order to get all of them to work together in harmony. So, display advertising, what's it about? And why is there going to be so much maths involved? Well, effectively, what kind of problem are we trying to solve? Somebody visits a website, and and of course, there's many such events happening in real time, and we have to make very quick decisions within tens of milliseconds as to which ad to show you. And of course, we have in practice hundreds or thousands of machines having to make these kinds of decisions in a split second. And so what you have here is, I'm walking through it, is it's a very large scale real-time optimization problem. It has elements of learning. It has elements of non-stochasticity, so non-randomness. I'd argue that perhaps behind high-frequency trading is possibly the second most large-scale and lucrative application of machine learning in the industry today. So just to familiarize everyone with the setting. So the idea is that some person, so that individual on the left there is actually one of our campaign managers. So say she is a market for boots, but did not get by. May have visited various sites, Zappos, your favorite shoe vendor online. And so, of course, that person might go about their day then visiting other websites or perhaps other mobile apps. And at some point, they land on a website where there's an opportunity to show an ad, but certainly there is unsold inventory. Now, unbeknownst to most of you, unless you work in advertising, there's a complex set of decisions that take place in the space of fractions of a second in the form of real-time auctions. And so what that means is that Washington Post here is going to send out requests to a whole bunch of bidders, which ad you want to show. You've got 10 milliseconds. And so that auction, of course, goes to multiple bidders. And like any auction, well, you know something about what you're buying. So here's an example of an auction where you're painting, and you know who painted it, time period, what it's about, and all that good stuff. And so we have a similar decision to make. Given this information in real time, we have to decide, okay, well, among the possibly thousands of ads we can show you, which one should we show? And so come back to the example, there's that real-time auction, and there's multiple bidders. So we're not the only bidder in this game that's being played here. There may be multiple other exchanges or demand-side platforms that are also vying to show you that ad in that moment. Now, ultimately, what this is all for? Well, what are the goals in advertising? Why is there such a business? Well, fundamentally, it boils down to the fact that advertisers have goals. They have objectives that they like to meet. That's why they come to Amazon. So among those goals, one of the most common ones that everyone's familiar with here is clicks. But one of the things that we actually do have quite a bit of power to deliver to the advertiser is additional types of user activity as goals. So what if Mr. Advertiser, you want to drive what we call consideration, so visits to a detail page on Amazon. Maybe you want to drive more web downloads or purchases on Amazon.com. Or perhaps conversions, you want to get people to sign up for a credit card, sign up for a phone contract, kind of stuff. And of course, as Amazon, we have one distinct advantage in this space, which is we know what to buy better than anyone else does. So that's a very, very attractive value prop for the advertiser. And ultimately, the kinds of things that we're beholden to, however, is of course we want to do a good job at being able to drive up conversions. Okay, so what we call response rates, so where those people are going to buy or purchase or download apps or whatnot. And we want to do this within some reasonable costs, in particular within the budget of the advertiser. Okay. So I'm not going to say too much about the other parts of the advertising business where Amazon also plays the role of a publisher and other intermediaries. That's talking for another talk sometime. So coming to the problem of ad allocation, so this decision of which ad should we show you, what are the kinds of things we should consider? Well, we should consider the user, the web page, and ultimately, the output of any algorithm we're going to come up with is going to be which ad should we show, and how much are we willing to pay to show you that ad once. Okay. And the complicating factor, and the reason why this is a 30-minute talk and not a 5-minute talk, is that we have advertiser constraints. Okay, so advertisers often have these annoying things like deliver my budget, deliver 100% of my budget by the end of flight time, or stick to this, get me a cost per action below some value. We'll give you examples of this. These actually turn out to be hard, even from a theoretical point of view, if you're interested in online learning and optimization. And just to tack on top of this, the kinds of additional challenges we face in practice are, well, in terms of scale, we're dealing with billions of requests per day, so that's a couple 100,000 opportunities to show ads per second, okay, on a global scale. So every time somebody visits a web page, someone will open something to add to it, that's not going to be shown ad. Have these annoying constraints and objectives, of which there can be multiple conflicting ones, but down to arbitrary between. We have to do all this, very quickly, within a few milliseconds, in online fashion. So this is an online learning home, which means there's no concept of going back into the past and changing your mind about which channel you showed 10 minutes ago. And last but not least, we have to do this across hundreds or thousands of machines and with real-time communication. So definitely not your textbook machine learning problem that puts in a single post. Now, I'd be lying to you if I said that we were the first people on Earth to think about this problem and come up with a solution. And sure enough, there's a good amount of work that's come out of the various teams at Google, Facebook, Yahoo, back in the day, Microsoft Research. And the methods tend to break up into two broad classes. The first are what I'll call approximation algorithms, right? So you basically, effectively, you show that ad allocation is a really hard problem, so we're screwed, so let's approximate the solution using this thing, and that gets you your paper somewhere. Second class of methods are, we're considered more heuristic. They tend to work reasonably well for more control-based methods. So treat the problem of trying to satisfy constraints as a control type problem. Okay, so here's how that as well. Of course, they both methods have their advantages. It's nice to have guarantees in adversarial settings, and I'll say a little bit more about that just a little bit. Control-based methods happen to be simple to implement, so we want to be able to capture both of these and also be able to have an honest discussion about the restrictive aspects, which has been discussed in some of this paper, to my great surprise. And the second, we like a method that actually can generalize to a number of ad allocation problems. So rather than reinvent 17 different algorithms, just have one algorithm for an algorithm to problems. Before I continue, I just want to make a distinction here between prediction versus control, because these often get confused, not just in the ad space, but in machine learning in general. So it's worth just spending a little bit of time on it. So in prediction, you're interested, it's typically, under a possible modeling problem, right? So predict what the user is going to do, measure that. So, estimate click-through rates, or predict whether or not a user is going to vote so that's one thing. That's different, however, from control, which is actually decision making. So using such predictions in order to make decisions that affect your person or the environment or something like that. And typically, in the course of performing control, you're trying to maximize some objectives, presumably business objectives. So I just want to emphasize that what I'm talking about here is really a control problem, not so much a prediction problem. I'm not thinking much about that first bit. Okay. So how are we going to think about this? Well, pretty much from its inception, from the very first ad server that was fired up back in the late 90s or something like that, ad allocation is fundamentally an optimal matching problem. Okay, so what that means is we're trying to match, on the one hand, opportunities to show ads to ads that we have. And we want to do this in such a way that we maximize the total value that we generate from doing this matching. Okay. So if you prefer, or if you prefer some other analogies, if you are Uber, the left-hand side corresponds to taxis, right-hand side corresponds to Uber users. If you're Airbnb, left-hand side corresponds to residences, right-hand side corresponds to Airbnb users. If you're a national organ donation agency, left-hand side will be donors, right-hand side will be recipients. Okay, so there's lots of examples of this kind of problem in applied science. So what we're going to do is, okay, we're going to try to match in the ad setting, give requests, opportunities to show ads with ads. And imagine that, on the left side, there's, a enormous number of these, so billions per day, right? And not only that, but they come to us sequentially, so that you don't get to see all of them in this nice little fashion. You have to make a decision on the fly. And otherwise, we have to do this given knowledge of, well, just how effectively, how much do we gain from matching a particular ad to a bit request, so the IJ pair presentation. Subject to the constraint that I can only show out one ad per bit request, and subject to these annoying long-term constraints, which are really going to make things hard for us. Okay. So the way we're going to think about this problem is to introduce what we're going to call assignment variables, those x's. They're just binary, okay? They're 0 or 1. They're 1 if I show an ad for a bit request, and 0 or 1s. So algebraically, the matching problem can be formulated as a linear program, or LP for short. Okay, where the goal is to maximize the total sum over all of the edges ij. Right? So each one of these ij's corresponds to a blue line. And I want to do this in such a way that the total sum over weights is maximized. And of course, I have a constraint that I can show up as one ad per bit request, and otherwise I have to have non-negative sections. And this term here that I circled, that's going to be our, effectively, our utility, if you like, of assigning an ad to a bit request. It's just our valuation, Dij, minus the price that we're going to pay for that bit request. So just very quickly, I lied a little bit. I said I wasn't going to talk about prediction. I'm just going to briefly mention prediction here, right? Because it comes up a lot. So typically, in the background, we have a model, a probability model that is able to produce this probability estimate. The probability that a user for a big request I is going to convert eventually a given ad. And typically, we use this probability to derive a valuation, which is just expected value. Right? So expected value for a new random variable is just a probability and some amounts of it. That's convenient, easy to compute. And otherwise, that Monterey amount tends to be specified by the advertiser for our purposes. Okay. So here's an algorithm that solved that problem problem that I just demonstrated exactly and fairly cheaply. So for each bid request, you can do this in completely online fashion. For each bid request, take all your candidate ads, rank them by this valuations, this expected value, and select the ad with the highest value. Then set your bid, within quotes, to be equal to this value. If that bid happens to be larger or equal to some concept of winning price, I didn't say anything about when the winning price came from, then congratulations, you get to show the ad. Hence, I said Xij star to one and measure, etc. Otherwise, too bad you lost, nothing happens, all the executives. Very simple, this is just ranking at the end of the day. Just pick the ad with the largest D. Right, just do this complete one on that. This is great because you can parallelize this across thousands of machines, and you can run completely on fashion. It's beautiful. Engineers love this. And life would be really that simple in advertising, and that'd be done now, except that upwards of a million constraints, which I'll get to in a moment. Before I get to that, here, just to establish some notation that vectors are going to be useful to us. So I'm going to slice up the time axis into actual intervals of walk time. Think of each of these boxes as 10 seconds of time, something like that. And within any slice of 10 seconds, there's a number of bid requests that we process and decisions that we have to make. And in the process of doing this, of course, we get some utility out of it. And in the process, we also get some constraints. Okay? So I'm going to think of the constraints here in terms of matrix vector products. Okay? If it helps, think of what I call matrix AT there as the amount of money I'm going to charge advertiser J if I serve their ad once. Right? So this is the kind of notation for the exact same problem, vector notation that I use. And now, those are going on constraints. So they're everywhere in advertising. They're actually the norm, not the exception. And they take on various forms that are as close to as possible to 100%, a budget by the end of flight time, achieve a CPA no more than some target, achieve some viewability no, but at least this amount, and there's many other examples as well. What makes them hard from an online optimization point of view is that they're defined, as the word says, as a long-term constraint. What you do in the given ground is not what matters, it's like how you behave over a long time period. If you take a long time period, it could be 3 months, like ad testing. So that's really annoying. Just to make this idea really concrete, here's one of those annoying constraints. Slightly more concrete form. So for a given round T, so remember a round here is 10 seconds slice. So my matrix A might be the matrix whose elements correspond to the budget consumed by ads for each bid request. And BT is some vector of target budgets, how much I should spend in a 10 second period. And I'm just going to define AX minus B as just a vector of errors in budget consumption for 10 seconds. Okay, so the reason I introduced that vector notation in there is it allows us to simplify notations at some level. So we're going to model this as an online context optimization problem. Okay, so what does that mean? It means that we're going to break up the time into a bunch of rounds, and each round in this 10-second period. And the game goes something like this. The player, that's us, we play a vector xt. Okay? That vector corresponds to the 0, 1 variables I described. The external world is going to respond with the reward u, and that's the vector utility that we get, right, from serving ads for 10 seconds. And a constraint violation of AX minus B. Okay, so that's the allocation vector, that's the performance, and then your budget and target, so that's your error. And then we want to make decisions in such a way that over T round, where T is a large number, we keep this error and constraint valuation small, right? So you don't want to overspend, you don't want to underspend. And otherwise, you want to maximize utility you get by extra things. That's the online context optimization problem we're going to solve. Now, some of you may be thinking, wow, who generates these A's or these U's or whatever? And the answer to that is equal wizards. No, but more seriously, what I mean by that is we don't actually make any assumptions about how the A's or B's or U's or various concepts are generated. In fact, they can be generated by the most evil, powerful beings in existence. And still in that environment, the goal is to come up with algorithms that do well in that kind of environment. Now, why would we do this to ourselves? Great question. I'm glad you asked. Well, because the kind of environment that we operate in display advertising is ever changing, and there's a whole bunch of aspects to it that really make life quite difficult. So I mentioned this idea of having to bid, to win production flow. You don't know what kind of auctions is being run. Developing ad serving code, introduce production new features. I mentioned these lovely campaign managers who are also making connections on the side. Well, that's all nice and good as part of business. At the same time, it's, they can be sometimes there's no governing model around that. So hardware failures to get the idea, right? So take all this together. Good old Black Friday, right? We love Black Friday. So take all this together, and you have the makings of a truly adversarial environment. So you want algorithms that do well in this environment. Okay. Right. So here's the algebraic form of the problem. Okay, so just as I said, we want to maximize utility and we want to penalize deviations in strings. Okay. And at first, that function e, so we introduce a function e here that's nonlinear, and on A in particular. The introduction of a nonlinearity seems to break that really nice ranking algorithm that I suggested earlier. But thankfully, a little bit of convex analysis shows that this is so. So what that means is, let's look at the first one, the ranging function. So take, function out of -4 and introduce a what's called a potential dual function, that funny e star at the end there. And the first thing you'll notice is, this function here remains linear in the x's. That's great. That's beautiful. It means I can keep on ranking. Except with modified values, now I'm going to rank with not just based on u, but also based on these dual variables and my a's. And so I can introduce these dual variables that are going to help me penalize deviations from strings. So the algorithm ends up being fairly simple at the end of the day. So again, we proceed in rounds. On the one hand, we're going to make decisions, okay, given a set of dual variables. That's what we call ranking bidding. And then, effectively, what we're going to do is we're going to look at that grade term is basically telling you what kind of mistakes did I make in the last 10 seconds. Okay, that's what that grade is telling you. Grading to like errors, right? And that's more or less the way they're introduced in college. And so, what mistakes did I make? And that's captured by that grading. And now I'm going to take a step, actual variables and update. And I just keep on doing this over time. The way this translates into a more applied setting is, so you might have on the orange rectangle here, you've got hundreds of machines making decisions in real time, okay? And they're just using the latest numbers that they've got, right? Every 10 seconds or so, of course, they're sending all their information back to the navigation feed that's basically just counting how much money have they spent for this app. Okay, that's the little blue boxes there. And otherwise, we're adjusting our dual variables, our lambdas, based on the error that we're making. It's very much like an integral controller. Right? And just do this in totally online fashion. And it works great. So, very quickly, let's get that line. So, a couple of things that we looked at here in terms of results. So here's a simulation that we did for these 6 ads, comparing our mapping from blue to, so green shows a proportional control heuristic, and red shows a kind of dual averaging scheme, both are on there. And so what you want in each one of these panels here is for the curve to compute to the 45-degree line. That basically says that you're able to stick to a particular fluid profile that we specified. And so red method tends to have a bit more variability than any of the other methods. And otherwise, in terms of the way it works in advertising is, you either get really good accuracy in how much budget you consume or how much performance you drive. You can't get both all the time. And so ultimately, this plot here shows that there's going to be trade-offs in doing this. So where you get very high performance, for example, you may have to give up on the constraint, essentially.
Some other results. So here's another smaller scale test that we did online. So this is our actual ad serving machine with 7 ads. Okay, so this is a proper A/B test. And here we're looking at, on the y-axis, return on ad spend, so ROAS. That's the Amazonian measure of advertising performance. Basically, how much money did we put into the advertisers' pockets from advertising with us because they sold lots of units of X versus how much they spent with us. Okay, so you want this, you want to come on the left with positive, and then in terms of delivery, you basically want all of these bars to be close to 100%. So that basically says that you're delivering on schedule, and so that's called on schedule behavior on the side. Okay. Yeah, so the large scale test that we did with large advertising pools, basically the exact same idea there. Just in the interest of time, let's go to this one here. Oh. So basically here we had, we looked at ads that were previously under-delivering or over-delivering, so neither of those are good. So we basically want an algorithm to increase both of those towards close to 0. So I'm sure you can see that here. And similar story for performance, you want less ads that underperform or overperform. That's more ads. That's actually all I had. So I'll talk to you about that.
All right, thanks so much. Great talk. I'd love to open up the floor again for another question and answer session for about 5 minutes or so. So if you have a question, please raise your hand and we're going to have a microphone run over to you. Thanks.
Hi, thank you for the excellent talk. So I just have one quick question, maybe a more complicated question after. So the first one is, did you have a problem with your gradient vanishing? Because you took the gradient of the Lagrangian, and by like PDT, you did the Lagrangian, and the gradient to 0.
So remember, we're not at the optimum, and this is an online environment, right? So in general, actually, that's what you want, but it's usually not what you get.
And this second one is, actually maybe this is easier. So like you gave the linear programming relaxation of the Boolean assignment, but I was wondering how you go from the optimal x values to actually assigning, because you can't actually, do you take like the R max or something? Or
Yeah, so a couple of things. One is that the relaxation in this case is exact, because the adjacency matrix of your graph that you're matching on is submodular, is TUM, right? So it's actually exact. Second of all, it's also the case that the only thing we need to do to compute solutions to that problem is the max operation.
Okay.
Yeah, that's all. Yeah. It's all improved, ad nauseam.
Could you define overachiever? Is that because it had too much click through, and so you couldn't sell another one? What's your definition of an overachiever?
An overachiever. Not sure what your.
I bet you were saying over.
Oh, so sorry. Yeah, I went through this slide a bit too carefully. I meant underperforming versus performing on par with expectations.
Did you have overperforming?
I had over-delivering. Yeah, that's.
And why is that bad?
Yeah, so over-delivering basically. So imagine that you're the advertiser. You gave me $10,000 for your campaign. I come back, hey, surprise! I spent $30,000.
No, it's not quality of the ad.
It's the amount of budget that we consume as a platform. That's right. But the converse of that problem is also bad. So again, you asked us to spend $10,000 on an ad campaign. We come back, hey, we spent only half of that. Actually, they also get mad at us for that as well. On the grounds of insufficient reach and
So it has zero to do with conversion.
Indirectly. Somewhat to do with reference.
Well,
Thanks. So I'm not too familiar with the primal dual method, but I saw it at a talk given this summer at the Data Science Summit by Professor Michael Jordan, and he was talking about using it for doing gradient descent and accelerating it. I was just wondering if you knew of other good uses of primal dual method other than for the optimization purposes, removing that sort of nasty nonlinearity in your constraint optimization that you were talking about.
Primal dual methods are actually very, very general. So those of you who are playing around with deep learning, you could technically solve deep learning using a primal dual method. There's also lots of good reasons why you wouldn't want to do that, but you could. It's a very general way of doing optimization. It happens to be particularly convenient here in the way it allows us to separate the problem into these nice little clean, simple pieces. But there's also lots of other examples where, like if you had a problem where it was hard to deal with constraints in primal, then you can try solving the dual and then go back to it. There's lots of applications for these kinds of methods beyond this. I mean, if you're asking like a practical application areas, I mean, just recommendations when it comes to time.
Any other questions? All right, well, that's our Q&A session. Thanks for coming out, everyone. Let's give Dr. Jim Huang another hand. And if you want to tweet the tweets and use the social media, our hashtag is CDAML, SDADAML, and I realized that I should have made that announcement at the beginning of the meetup, but like a machine, I'm learning as well, so thanks so much.